Hey everybody, this is Alex Merced, and I'll be hosting today's episode of Select All from Data Lake. And today what I want to talk about is just like what is a data lake table format, because it's a really hot topic. You always hear about these things like Apache Iceberg, Apache Hoodie, a Delta Lake, and there's a lot of like fierce sort of differentiation going on and whatnot. And the idea is sort of like, but why? What is this thing? What is this table format thing? So let's talk about that. So always the best way to understand like what the thing is to understand sort of the why. What is the problem that this is a solution for? Okay, so I think I might have talked a little bit about this in the previous episode, but we're going to elaborate more on it today. The general idea that people want to do more on their data lake. So at some point, people started to try to do more on their data lake using like Hadoop to store data. Then it was like MapReduce, which led to Hive and so forth and so forth. And eventually you were able to represent tables on your data lake using a format called Hive, which tracked the tables. Basically, the fundamental way it tracked whether this data was a table or not was through directories. Okay, and what do we mean by that? Well, think about the way you've ever used a database or a data warehouse. So generally when you go into a database or a data warehouse, tables just kind of exist. Okay, you're not thinking about, hey, what files make up this table? You just query the table and you get data back. There's a certain sort of like, it's just kind of all the implementation details, all of how the things work, they're all under the hood and you kind of take them for granted. You pay for that though, okay? You are paying for that sort of like, hey, everything is nice and tidy for you in a box experience, okay? So the idea is, hey, if I can kind of replicate that same experience by assembling a bunch of pieces together, I can get the same benefit but a much lower cost point. That's sort of like what people want out of the data lake. The idea is like, hey, how much can I squeeze savings out here? Okay. But to have that experience like a database or a data warehouse, there has to be a way for users to just look at the data as tables. Okay, they don't want to sit there and think, oh, okay, there's 1,000 Parquet files, and I want to query this particular 200 Parquet files. That requires a lot more wear and tear in trying to think through what you're doing, and that wear and tear means it takes longer to think through what you're doing, which means time is money. So the idea is if I could look at the data, the sea of files that are stored on my data lake, because again, really what your data lake is just a place to store data. Whether you're using Hadoop, a file system, whether you're using a cloud object storage file system, it's a file system where you just have a bunch of files. Okay, so your monthly, all your sales data might be stretched across 1,000 Parquet files, 10,000 Parquet files, and so forth. But when you say, hey, get me all the sales that match this query, you're not thinking about 10,000 files, you're thinking about your sales data as a unit, okay, aka a table, a data set. And that's essentially why there was a table format. The idea was like, how can we say that these files are a single data set? So Hive would do that based on a directory. It said, okay, hey, if all the files are in this folder, that's a data set. Okay, so all the folders, all the files in the folder called table A, that's table A. All the files in the folder called table B, that's table B. And that worked fine when it came to reading for the most part. Okay, I mean, you could speed up your reads through things like partitioning and whatnot, but it could be better. And then on top of it, when it came onto the right side, if you wanted to update the data, there was all sorts of challenges with concurrency, safety, all sorts of that. So it worked well for being able to read data in your data lake for the most part, but fell short of a lot of the needs for people to really actively move their data from basically say, hey, I want to use the data warehouse less. Okay. So you had this new generation of data lake table formats. Okay, so these are the ones I mentioned earlier. I'll go through them in a second. But essentially what they do is they generally are going to track not just sort of what files are in the table, but they're generally also going to track the changes in the table over time, so that way you can do things like time travel, so that way you can actually query the data as it was, let's say, a month ago. To be able to do things like be able to change the schema of the table pretty easily, to be able to do concurrent transactions safely, have what's called an asset guarantee. So basically, Atomicity, so basically, it's all or nothing kind of changes. Consistency, so the data is always the same no matter where you're looking at it. Isolation, so you're just kind of isolating these changes in the data. Okay, and durability, where basically that data is going to be sort of safe and sound. Okay, so these kinds of guarantees are what these formats are trying to do. They say, hey, you know what? You don't need a box. You don't need a data warehouse box or a database box. You can have this thinner layer called the data lake table format over your files, and you can interact with your data like you would a database and have a lot of the same guarantees and flexibility as you would with a traditional database. Okay, and there's 3 of them. Okay, those who follow me know probably I spent the most time talking about Apache Iceberg. And Apache Iceberg, basically what it does is it breaks down the way it tracks tables into sort of 3 layers. So basically you have like a layer of metadata that tracks the table as a whole, another layer of metadata that tracks the different isolated snapshots, and then a layer below that that tracks sort of like groups of files that make up the table at that point in time. Okay, and there's a lot to be said for that. Again, this particular episode is not going to be an in-depth Apache Iceberg episode. There will be one in the future, but we're not there yet. Today is just sort of high level, hey, what is a data lake table format? Then you have Delta Lake, which basically tracks kind of similar to the sort of the when you think of Git. So like if you ever use Git, what does it do? Like it tracks the changes in the lines of codes from one snapshot to another. So essentially, you have the original snapshot that's really all adding lines of code, and then the next one says, okay, add these lines of code, subtract these lines of code. That's how Delta Lake works, where basically each file is a delta of the previous snapshot. So you have all these delta, what's called a delta log. So then the next delta log will say, okay, well, these files were added, these files were subtracted. Then the next delta log is, well, these files were added from the last one. And then essentially, if you can rebuild the table by following them in sequence, okay, and then later on you can summarize them through like checkpoint files and whatnot. But that's essentially the idea there. Okay, then you have Apache Hudi, which similarly, but except what it does, it basically has like a theoretical timeline. So basically every type of action on the table is timestamped and categorized. Okay, so sometimes you're changing, sometimes you're doing like optimization type techniques, and I'm not quite sure like sort of like what the algorithm is, but essentially it uses these timestamps to construct the table. So it's going to basically say, okay, these transactions occurred at these times. It can see, hey, what types of transactions they are, and based on that, it can then recreate the table. Fast forward not just between snapshots, but like between specific like actions that occur to the table, because it's essentially what you're doing is you just have a huge timeline of actions instead of a bunch of sort of like individual logs or snapshots. Okay, and again, each of them were built for different purposes. So like Apache Iceberg was particularly created to deal with issues with performance with Hive over there at Netflix. Okay, and Delta Lake was created sort of to help the Databricks product in the sense that, okay, hey, now Databricks has this format that it can write to that will really be beneficial to the Databricks sort of tools. And then Apache Hudi was built for Aruba specifically for like streaming data, so it's really like built with streaming in mind. So all of them sort of like started in a different place for different use cases, which is why like their architecture is different. While they're all kind of solving the same problem, they're solving it from a different point of view, which leads to sort of like the way their features have evolved. So generally, over time, all of them are, they started with X, having X features and missing Y features. Nowadays, they generally, for the most part, have most of the features that each other has. They generally work differently, can perform differently on different engines. So at the end of the day, like, hey, what should you use? It depends. What tools are you using? Okay, because one, some tools may not support one of these formats. Two, different engines will perform differently on these formats. But at the end of the day, like they're all going to provide you that layer above Hive where you have like asset guarantees, schema evolution. Now, of course, there are a couple features that are sort of unique to each one. Again, not going to kind of go there for this episode. This episode is just more to understand sort of like what their role is. And then again, you have also projects out there that are also working on interoperability between these formats. So chances are moving between these formats will become less of a consideration as well. So, it'll be less of a deal breaker to say, hey, this is the format I'm going with. As far as what tools you can use and things like that. So there's still a lot of things to be figured out Okay, and it's not just the format, but it's also like how do you track those tables? So like an interesting conversation in the future will be the catalog, the mechanism which you use to track the existence of these tables, and that to me I think is sort of like the next big conversation as an industry to be had once things kind of settle down in the table format. So like now we know how we want to recognize our tables, but now how we're going to catalog those tables. So that's a kind of interesting conversation to look forward to when we get there. But yeah, hopefully you found this interesting to kind of understand like, okay, hey, again, people want to use less, have their data kind of stuck less in a box like a data warehouse and database, but they still want that feel. And that's what the data lake table formats do. They allow you to kind of give this layer that'll give you that database feel while still having your data sort of in this nice open location that all tools can access instead of just the tool that the data is stored in, like a database or a data warehouse. So have a great day. My name is Alex Merced. You're listening to Select All from Data Lake. Have a great day and enjoy.